At the core of every modern aircraft lies a marvel of engineering: the jet engine. For a passenger jet like China's C919, the engine is the single most critical component, dictating its fuel efficiency, range, and reliability. The immense thrust required to lift hundreds of tons into the sky demands technological mastery that only a handful of nations possess. The global market for large commercial jet engines has long been dominated by a select few companies, making the technology a closely guarded strategic asset. For China, powering the C919 with a domestically produced engine became the final frontier in its quest for technological independence. The story of the C919's engines is not just technical, it's a geopolitical saga, revealing how a single component can define a nation's ambitions. Economic sanctions are a primary tool for nations to exert influence without direct conflict. By imposing restrictions on trade, finance, or technology, countries can pressure others to change their behavior or policies without resorting to military action. Sanctions are often used as a diplomatic lever, signaling disapproval and attempting to force negotiation or compliance. These penalties can freeze assets, block trade, and disrupt the flow of goods and money across borders. They can target entire economies or specific individuals, companies, or sectors, making it difficult for the sanctioned party to operate internationally. Sanctions can also restrict access to critical technology, like jet engines, advanced electronics, or specialized machinery, hindering a nation's ability to maintain or develop key industries. The U.S. uses sanctions to isolate adversaries from global financial and trade systems, leveraging the dominance of the dollar and Western institutions. This financial power means that even countries not directly involved must often comply, or risk losing access to the world's largest markets. Secondary sanctions force global businesses to comply, creating a chilling effect. Companies worldwide must carefully navigate these rules, or face severe penalties themselves. In the Russia-Ukraine conflict, sanctions aim to starve Russia's war machine of technology and funds, hoping to weaken its military capabilities and economic resilience. Yet targeted nations often find creative ways to circumvent restrictions, developing alternative trade routes, using third-party intermediaries, or turning to black markets to obtain what they need. They may also deepen partnerships with other sanctioned states, forming new alliances and economic agreements to bypass Western controls. This is exactly what's happened between Russia and China, as they collaborate to build a parallel economic ecosystem immune to Western pressure. Their cooperation includes new payment systems, trade in local currencies, and joint ventures in critical industries. The struggle over jet engine supply is a perfect example of this high-stakes, clandestine battle, where technology, strategy, and global politics collide in the shadows of international trade. In the world of international trade, sanctions often give rise to intricate evasion networks. These networks are not just the work of a few individuals, but rather sprawling webs that span continents, industries, and legal jurisdictions. They thrive in the shadows, adapting quickly to new restrictions and exploiting every loophole available. The transfer of sensitive jet engine technology from China to Russia was enabled by a complex web of companies designed to obscure ownership and transactions. Each layer of this network was carefully constructed to hide the true nature of the deals, making it difficult for authorities to trace the flow of goods and money. Two Russian nationals, Evgeny Petrov and Konstantin Smirnov, orchestrated a network stretching across China, Bulgaria, Estonia, and Russia. Their operation was sophisticated, involving multiple shell companies and trusted associates in each country, all working together to keep the supply chain hidden from prying eyes. Engines were shipped by a Chinese company, officially owned by a Bulgarian firm, which was in turn owned by an Estonian holding company, ultimately controlled by Petrov and Smirnov. This multi-layered ownership structure was designed to create confusion and provide plausible deniability at every step. The engines at the center were produced by Xiamen Limbach Aircraft Engine Company, sanctioned by the US for aiding Russia's drone program. Despite international scrutiny, the company continued to find ways to move its products through indirect channels, highlighting the persistent demand for advanced technology in conflict zones. Despite sanctions, the network funneled engines to Russia's defense sector, exploiting EU-registered front companies for legitimacy. These front companies provided a veneer of respectability, making it harder for regulators to detect illicit activity and allowing the network to operate in plain sight. Trade data confirmed direct shipments even before sanctions were publicized, revealing a well-oiled machine for circumventing restrictions. The network's ability to anticipate and adapt to new rules made enforcement a constant challenge for authorities. This case shows that sanctions require constant vigilance. Those determined to defy them will always seek new routes. As enforcement tightens in one area, evaders simply shift their tactics, using new intermediaries or jurisdictions to keep their operations alive. The Petrov-Smirnov network is a stark reminder. Economic pressure alone rarely stops determined actors. Only through international cooperation, robust intelligence sharing, and relentless monitoring can authorities hope to disrupt these sophisticated evasion schemes. For decades, China's aerospace industry was hobbled by its dependence on foreign jet engines, especially from Russia. This reliance not only limited the country's military ambitions but also exposed a critical vulnerability in its quest for technological independence. Every new fighter jet or bomber that rolled off the assembly line was a reminder of how much China still depended on the expertise and manufacturing prowess of others. Early attempts to reverse engineer Soviet and Western engines failed, highlighting the immense complexity of the technology. The intricate metallurgy, precision engineering, and advanced materials required for high-performance engines proved to be formidable obstacles. Chinese engineers often found themselves facing setbacks, as even minor flaws could lead to catastrophic failures in the air. Russian engines like the Saturn AL-31F powered China's frontline fighters, keeping Beijing tethered to Moscow's lead. This dependency meant that any disruption in relations or supply could ground entire fleets, making self-reliance a strategic imperative for China's military planners. The domestic WS-10 engine suffered reliability issues, but this only galvanized China's resolve. Each setback became a lesson, fueling a determination to master the science and art of jet engine design, no matter how long it took. In 2016, China consolidated its engine R&D into the Aero Engine Corporation of China, AECC, launching a unified push for self-sufficiency. This move brought together thousands of engineers and scientists under one roof, streamlining research and accelerating progress. Backed by billions in investment, this state-driven approach mirrored China's successes in high-speed rail and space. The government's commitment was clear. Mastering jet engine technology was now a national priority, on par with its most ambitious infrastructure and scientific projects. By 2020, China had invested over $42 billion in jet engine R&D, and the results began to show. New facilities, cutting-edge laboratories, and a growing pool of skilled talent signaled a new era for Chinese aviation. Years of reverse engineering and original research started to pay off, slowly closing the gap with global leaders. Chinese engineers began to innovate, not just imitate, developing unique solutions to long-standing technical challenges. China was no longer content to be a customer, it was ready to become a creator. The long march in engine technology was finally bearing fruit, setting the stage for a new chapter in the nation's aerospace ambitions. As Moscow and Beijing's partnership deepened after the Ukraine war, Washington grew alarmed. The US saw Chinese technology as a lifeline for Russia's war effort and responded with targeted sanctions. In October 2024, the US sanctioned Xiamen-Limbach Aircraft Engine Company for supplying engines to Russia's drone program. The strategy aimed to punish Chinese entities and send a warning to Beijing aiding Moscow would have consequences. Yet Russia and its Chinese partners proved adept at navigating sanctions, using elaborate evasion networks. The Petrov-Smirnov case showed that sanctions forced cooperation into the shadows, but didn't stop it. When two major powers are strategically aligned, economic pressure alone rarely severs their ties. High-stakes technology trade continues, driven by shared geopolitical goals. After decades of effort, China's jet engine program has finally achieved real breakthroughs. The Shenyang WS-15 engine now powers the J-20 stealth fighter, ending reliance on Russian engines and unlocking its full potential. The improved WS-10C engine has become the workhorse of China's Air Force, proving reliable in demanding roles. China's progress extends to strategic transport. The GNY-20 is now powered by the domestically developed WS-20 engine, boosting range and payload. These successes are the result of massive state-led investment and the focused leadership of AECC. China has solved critical reliability and production issues, fundamentally altering its position in global aerospace. Mastery of jet engine technology marks China's arrival as a true aerospace power. The deepening Russia-China aerospace partnership, forged under Western sanctions, has profound geopolitical implications. It signals the rise of a new strategic axis, building an alternative technological ecosystem outside US influence. By collaborating, Moscow and Beijing accelerate each other's rise, challenging the dominance of Western manufacturers. China's C919, once equipped with a domestic engine, will compete globally, especially in markets seeking autonomy from the West. The ability to offer a sanctions-proof package makes China and Russia attractive partners for many nations. Their success in circumventing sanctions undermines the credibility of economic statecraft as a Western tool. The world may be heading toward parallel economic blocs, each with its own supply chains and standards. China's self-sufficiency in jet engines closes a critical gap, redrawing the map of global power. The Russia-China jet engine saga captures the central tensions of a new era of great power competition. Their ability to overcome US constraints marks a fundamental shift in the geopolitical landscape. As China refines its engine technology and moves into the commercial sector, it will challenge Western aerospace giants. The next battle will be for market share and setting international standards, with China and Russia offering a sanctions-proof alternative. For the West, the era of assumed technological superiority is over. It must now be continually earned. The story of these engines is a microcosm of a larger global struggle for technological sovereignty and influence. What happens next in jet engine development will be a barometer of global power in the new Cold War of the skies.